Hi everyone. This is Ria. She has completed her meeting and waiting for a taxi to go back to her home. The taxi driver arrives at her place and asks her,
"Hello madam, do you want to hire a taxi? And it just costs ₹5 per kilometer only."
Oh. That's great. The fare seems reasonable. Let's go.
On her way back home, Ria notices that, for her first kilometer of the journey, the fare was displaying as ₹5. The ride reaches the second kilometer, the fare increases to 10, and for every kilometer she travels the fare increases to 15, 20, and so on. Ria knows that the total distance of the journey is 40 km. She is curious to know what would be the fare at the midpoint of the journey, and also wants to compute total fare for the entire journey. Let's help Ria to compute the values in a much easier fashion. Let's imagine the distance traveled in kilometers and their corresponding fare in the form of a table. The table will have running numbers starting from 1 till 40, where 1 represents the first kilometer traveled. The number 40 represents the total distance of the journey from Ria's office to her home. Each number above each kilometer represents their respective fare amount. Let us represent the first kilometer traveled as T1, second kilometer as T2, third kilometer as T3, and so on. As per our assumptions, T1 equals 5, T2 equals T1 plus 5, T3 equals T1 plus 5 times 2, T4 equals T1 plus 5 times 3, and so on. When we look at these equations closely, we can infer that the fare for the second kilometer of the journey T2 is the sum of the fare for the first kilometer of the journey and 1 times fare of the second kilometer of the journey. Similarly, the fare for third kilometer of the journey T3 is the sum of the fare for the first kilometer of the journey and 2 times fare of the second kilometer of the journey. Thus we can generalize the equation as, for any nth kilometer of the journey, the total fare would be the sum of the fare of the first kilometer of the journey and, n-1, times fare of the nth kilometer. That is, Tn equals T1 plus n-1, 5. In the above equation, the number 5 is a constant and can be represented by the letter D. So the above equation can be written as Tn equals T1 plus n-1, D. The formula which we derived is known as formula for nth term of an arithmetic progression, where Tn is nth term, T1 is first term, D is a common difference, and n-1 is nothing but a term position. Using the formula which we derived, we can easily calculate the fare for the 20th kilometer of the journey, which is nothing but the fare at the midpoint of the journey. Substituting the value of n equals 20 in the equation, we get T20 equals T1 plus 20 minus 1, times 5. Which implies T20 equals 5 plus 19 times 5. Which is 100. Thus the total fare at the midpoint of the journey will be 100. Now, having found the fare at the midpoint of the journey, our next task would be to find the total fare for the entire journey. For that, let us consider the sum of first in terms, which is equal to S equals T1 plus D, plus T1 plus 2D, plus T1 plus n-1, times D. Writing the terms in reverse order, we have S equals T1 plus n-1, times D, plus T1 plus n-2, times D, plus T1 plus n-3, times D, plus T1. Adding both the equations term-wise, we have 2S equals 2T1 plus n-1, times D, plus 2T1 plus n-1, times D, plus 2T1 plus n-1, times D, plus 2T1 plus n-1, times D, in terms 2S equals n times 2T1 plus n-1, times D. S equals n/2 2T1 plus n-1 times d. This is the formula for the sum of n terms in a series. We will use this formula to calculate the total fare for the entire journey. S equals n/2 t1 plus n1 times d. In our case, n equals 40, t1 equals 5, and d equals 5. On substituting these values we get, s equals 40 halves, 2 times 5 plus 39 times 5, which gives, s equals 4100, which is the total fare that Ria has to pay to the taxi driver.
Thank you for the ride. It was a pleasure traveling along with you. Goodbye.
Goodbye, madam.